Alright, so today I'm going to be cutting some orifices. Um, I deal in, doing these orifices. I started doing them because I was doing a number of cooktops and stoves and stuff, and there weren't orifices available. So, basically you'll see orifices, the gas goes through them, and then it goes through the ignition system, and then it ignites at the base of the burner, or whatever it is. I do them for barbecues, do them for cooktops. But basically, that's not really the issue today. What I'm doing today is I'm going to be turning some of these out. Now, I have a number of different types of orifices. So this one here is a little bit more of a complex orifice than what I'm going to be doing today. It's got a 30-degree bezel at the top here. The hole's not drilled in it. I leave them blank usually, so I can size them to the application. This one was I cut this shank down too much, so this one's useless. It's just a wasted piece of material now. But normally, you're going to drill through here, and then you're going to drill a tiny little hole here, and the gas is going to come out and everything. But as you can see, it's made out of hex stock. So, but I'm not doing that type of orifice today. What I'm doing is I'm doing a very simple version of an orifice, which is this style. Okay, threads. It's got the hex stock. Basically, these are 90-degree cuts, got the hole drilled down in the middle of it. Just basic stuff, really. I just want to show the basics of using a lathe. So, everything is cut on a lathe. The only operation that I don't do on a lathe is actually cutting the stock across, because I don't have the exact setup right now that I need to be able to put a cutter on here to cut with any accuracy. I'm working on getting one of those right now. So I can cut it with the blade, and do a nice clean cut. That has to be a really precision setup, and what I want to do is I want to get like a quick chuck for this, so I can just swap out these blades as I do, the different operations. Basically, this orifice here only takes one, well, I think it's one type of blade, okay? So I'm going to be using that, and as you can see, got like a little mini lathe, I mean, we're only working with brass here, so I don't have to have a super duper lathe to be able to do this. There's my drill chuck. That's how I center drill those pieces. Here's where I set up my cutters, that one and that one. This is the main cutter that I use here. As you can see, it's got the little head here, and then I chuck in the pieces as I go along here. It's got, basic lathe stuff. It's got reverse and forward gears on it, so it can spin in reverse or forward. And that's critical to the type of cut that you're doing. It's got a speed adjustment here, on and off switch. So it actually has to be at 0 RPM. In other words, it has to be stopped before you can turn it on. And then the reverse and forward has to be specified before you actually do that as well. So that's basically what I'm going to be doing. It's got a little table on here, kind of shows the different things here. Little indicator table, So the one thing that you have to remember when you're using a lathe is that the speed is critical to cutting the material. And if you have a basic machinist handbook or resources available on the internet, they'll tell you that depending on the material will depend on the speed that you're cutting. So you kind of have to know how big the diameter is, and that's going to determine the speed that you're cutting. Okay, so that's one of the things about the lathe. I use a number of different sizes of hex stock. So today I'm going to be cutting this small stuff, but I mean, I go up to hex stock that's this big, and hex stock obviously has got 6 sides. Now this is American hex stock. It's got American sizing on it, so these are standard sizes. There is also metric sizes available, but I don't usually use the metric sizes. In fact, a lot of the orifices that I'm doing this for are metric orifices. So what I'm doing is, when I'm doing the replacement orifices, I'm actually doing them in standard sizes. So whoever the end user has to be using standard sockets to be able to turn this into whatever they're installing it into. So that's kind of important. With each operation that I do as I turn down the stock, I'll go from a hex stock like this, right? I'll go from that to a round you know, because obviously I'm turning down the stock. And on this one here, there's a little bit of a bezel on this edge here. So, and that's because I have the cutting piece tilted, and that enables the cut to go smoothly without any binding. If there's binding, you know, it makes quite a mess, and what it ends up doing is it ends up bending the hex stock if that thing jams at the source there. So I try to make it to where it's going as smoothly as possible. So as you can see right now, I've got this cutter turned at about you know, a 20 to 30 degree angle, you know, in reference to the axis right here. So, you know, about 20-30 degrees, that's what the angle is there. And that's a pretty effective cutting angle. You know, now, if I were doing these pieces here, what I would be doing is I would be doing the swings here. So I would actually be tilting this out, and then I would be driving it in this direction to cut across the face of this head. But again, that's not what I'm doing today. And I probably will end up doing a video doing those orifices. These ones involve more complex cuts than these orifices here. These are just very basic, simple orifices. And, you know, I'm just a basic guy. I do basic operations on this lathe. There are a lot of really elaborate operations that you can do on a lathe. You know, that's not what I'm in the business of doing. I'm in the business of, you know, making parts on a lathe that are very simple, and I don't make them out of hardened steel or even mild steel, just because, you know, this lathe, it doesn't have enough power to really work with steel very well. I mean, I could cut through there, but I'd only be able to cut maybe 1 or 2 mil at a time if I was using steel stock. So the lathe is pretty much useless for that. But for other softer materials, you know, like brass, like what I'm using, it works just fine. So the operations on the lathe, you know, all the steps that I go through as I get towards cutting these shanks here, okay, I'm always measuring to see what my final measurement is, you know, because the outside measurement is important before I tap this. So I'm always using my calipers as I go along here. The one thing you have to remember when you're doing cuts on a lathe, for each millimeter that you're doing of a cut, okay, or each thousandth of a millimeter or whatever it is, you're actually doing 2. So let's say you're doing, you know, like a 10,000th of an inch. You're going to cut in 5/10,000ths of an inch. Well, actually what you're doing is you're reducing the size of that shank, you know, 10/10,000ths. You have to remember that because you got 2 sides and it's turning in a circle. So it's actually doubling the amount of cut that you're doing when you're cutting stock like this. Okay, so that's the one thing you have to remember about using a lathe. And again, you always want to be cognizant of the direction that head is moving. In this case, I've got it moving in a forward direction, so it's going to be moving in one direction. If I had it reversed, I'd be normally when I cut these heads here, I'm cutting on the back side of the head, so that's the only time I would ever use that machine in reverse for what I'm doing anyway, you know. So if you're cutting on the back side over here, you're going to be in a reverse direction because the cutter dictates that. If you're cutting on this side of the head, which that's all the operations that I'm going to be doing on this particular piece, I have it in a forward. I've got it set for forward cutting. So I'll go ahead and set everything up, and I'll get my stock in there, and well, basically, I guess I can start to do that now. Well, let me kind of plug everything in, get everything ready to go, and then I'll come back on camera. Now, the other thing too about these lathes is that, you know, typically when you get one of these lathes, you know, they're not exactly usable right out of the box. You kind of got to get them set up, and you got to get them set to the point of where you can actually use them effectively and accurately, and that the accuracy part is based on proper setup. So I'll come back on camera after I've got a few things set up here. Okay, so, you know, I've shown the stock here. What I do is I try to do one operation at a time, and I just repeat it because it saves me a lot of time. I don't want to just take one of these and do every single cut on it and turn the piece around and line it all up, because I mean it requires line up time also. So what I do normally with this stock is I've cut it down into a bunch of pieces, and then I do the first operation on each piece of stock on each end of the stock, and then I run it through, I cut it off, and then I do the rest of the operations on the other end of the stock. And I always repeat the same operation on each phase of building these pieces. So now what I'm going to do is I'm going to go ahead and chuck up a piece of stock in here. You always want the end of the stock to be as close to the barrel of as close to the chuck of the lathe as you can. And you always want to make sure that you have it properly chucked up in there. So, it's standard head. It's got a chuck key just like this. This has got a spring on it, so you don't actually leave it in there, because if you turn it on and it goes around, it's going to hurt somebody or hurt something. Okay, and then I just kind of load it in there. Make sure it's all loaded in. Okay, jaws are locked down. So that's about how much stock I'm going to need to do. This part of the cut here, the threads, the barrel part of the cut, the shank part of the cut. Okay, then what I'm going to do is I turn it on, and I just make sure that it's not moving around. Okay, so now I know it's centered. Okay, so I'm ready to start cutting. On this particular cut, I go about halfway here, so I go to about 900 to 1200 RPM. So I'm going to go ahead and do that. And well, first of all, what I'm going to do is I'm going to line up the piece. So I want to get it right there at the end. So I just kind of take this guy. And the other thing that's critical about this is, since I do have this tilted back, I want to make sure that this is not going to come into contact with any of these pieces, even as I cut downward. So I always want to make sure it's clearing. That's why I got to leave enough on the end here. Okay. So this piece here, actually, well, first of all the pieces need to be shaved down first. So that's going to be the first thing that I'm going to do. I'm going to shave them all down. So let me go ahead and get this loose. And I know that this piece here is centered with this, so that's why I can run it across the face of that. But what I'm going to do is I'm going to flatten them all out. So I'm just going to keep running them through there, flattening them out, and then I'll go in to do the second cut after this. So just going to get it to the center here, as far as I can see, and you can probably measure that if you had to. I just kind of eyeball it, so that's where it's got to be right there. Okay, and then what I'm going to do is I'm going to turn the lathe on and go to the center of it. And I just kind of cut outwards. I'm going to cut it a little bit more. I want to kind of show you from this angle here. As it cuts. Kind of hard to get an angle on that. Let me go up here. Let me see here. Alright, so now I'm going to start cutting here. And I always just go to the center of it, because that's where the cut needs to originate. I don't want to go on the back side of it because I've got the lathe turning in one direction. So just kind of face it off here. I go inwards from the back, and I start from the inside out just because I want to get that. I don't want to have a little peak on the piece there as I'm cutting through. So I'm just going to check it real quick to make sure I faced it off correctly. And it appears, I can't get my head in there. Okay, so it appears that I have faced it. So basically, at least I'm hoping I did. Well, if I didn't, it'll be evident. Okay, so I'm going to move this out of the way here. I'm just going to go ahead and take it out of there. And I'm just going to do each of these pieces. I'm going to do it, I think it's about 12 times. I think that's how many pieces I have. Okay, so as you can see, I've started to face it here, but this side here isn't faced. So I'm going to go ahead and face it all the way across, and that's what the entire piece is going to look like this once I'm done. And that way I know that it is at a 90 degree to, to what this is right here. So I'll go ahead and get that part done, and then I'll come back on camera and do the next step. Oh, one of the things I wanted to point out was this is the screw for turning the piece inside and out, which actually drags the cutter across the face of the piece. So when I crank this, I try to crank it at a very consistent rate, because the amount of the speed that I crank it at is going to affect the cut, and I don't want to go too fast and go into too much material at one time, because otherwise it's going to jam like I pointed out before. I'm not cutting off a lot of the face of the material. I'm probably cutting about 5 or 8 thousandths, something like that. So I just wanted to point that out, and I am always consistent with the way I cut it, and I always do the same piece. I put it in there, I do the same cut every time, and the reason is as a matter of consistency. That's why I only do one cut at a time on this. If this was a programmable lathe, yeah, I'd have it do a bunch of different cuts and crank out one piece at a time. All the cuts would be done. That's just not the case here. So that's just kind of what you have to do when you're working with a lathe that is a little hobby lathe. Okay. So as I draw across the face of the material, what it does is it obviously makes it to where it's going to go from the rough cut like we saw there to something like this, to where it's nice and smooth all the way across. Okay, this doesn't have to be perfect for what I'm doing. Okay, if it had to be perfect, I'd be doing this a completely different way, but I just wanted to show you that. Okay, so now I'm going to go ahead and show a cut being done. I'm hoping this is a good angle here. I'm not sure. Kind of show a cut being done as it's going along there, just to kind of show you what I'm seeing. So I'm going to go ahead and do that. I think I'm going to zoom in on it. Let me try that. There we go. Okay. All right, so there's the face of the material, there's the cutter. Okay, so as you can see, the face of the material is rough cut. That's because I cut it on a bandsaw. Okay, I've already checked it to make sure that it's centered. So it's centered, it's not moving around. Okay, it's actually working, and you can see from the way that it's turning, since the face is moving around, that face is not cut evenly. So I'm going to cut it to where it does cut evenly, and now we're going to do it right now. And I go up to about 1100 RPM. There's actually two speeds on this, so and I have gears that I should probably point this out. There are two sets of gears in the gearbox that determine what the fastest speed is here. Okay, so the low setting is at 1100 RPM, and it can go up to 2500 RPM depending on the gear ratios that you have in the box in the transmission of the unit. So I've got it on the low setting. So what I'm cutting at is it's about 600 RPM, 500 or 600 RPM, somewhere in that range. So I misspoke before, but you kind of get the idea here. Okay, so now I'm going to go ahead and cut it. With that cut, I'm going to bring the cutter right up to the face of the material. I'm standing back away from the material so that if something comes flying off, it's not going to hit me. I'm like more towards that side of it. Okay, try to get the idea there. Okay, so just want to make sure that nothing's going to hit me. And I always start at the center on these pieces because it's kind of hard to get that centered without having a consistent setup. So, and as you can see, I'm drawing it out, and that's actually what it looks like when I'm cutting it across. Turn it off here. Okay, so you can see that part of it's cut off, but part of it's been smoothed out already. But this part here is still, is still unsmooth. So I'm going to go ahead and go back in there. Let me go ahead and turn it off. Okay, turn it back on. Draw it to center, crank it in a little bit, and draw another cut. Now the other thing too about cutting here is depending on the cut, I'll either use lubricant or not. You can hear it kind of squealing a little bit, but that's not because it needs lubricant, it's because it's... Okay, so now we're cut all the way across. So, if I'm doing a high-speed cut, I'll usually use lubricant. WD-40 works out pretty good, but there's actually cutting fluids that you can use on lathes, So if you're doing super high cuts on steel, boy, that's really critical. You got to be running lubricant through there, and it's be splashing on the piece as you're going, as you're actually cutting it, and that keeps it cool. It keeps anything from because as it gets hotter, it expands and then it contracts, right? So to use the cutting fluid on larger pieces, that's something that you're going to be doing in a high-speed operation with different materials. Now I do use the WD-40 for cutting the pieces on the lathe here. Usually I'll do that when I'm doing these bezel cuts because I want this cut to be nice and smooth. So I'll run some WD-40 in there. But like I said, it's not really, I use it, but it's not really what you would see in the machine shop typically. Typically you see cutting fluid and it'd be running through there and it'd be cycling through a machine and then pump back up into the head of it, and then just keep going back and forth through there. So you kind of saw how the cut go, and then now what I'm going to do is I'm going to come on camera when I have all the pieces done. But so far what I've got is I've got these two pieces and that piece now, half of that piece done, so they're nice and smooth on the ends here. So I'll come back when I get them all cut. Okay, so you might be saying to yourself, why is this guy cutting making sure that the ends of these are machined smooth if he's just going to drill them through? Because I'm going to turn down this is going to be the shake part right here, okay, at the end, and then I'm going to drill through it. So why would I want the end to be smooth like that? The reason is because I want to make sure that I have a matter of consistency for how long I cut the shake of this material. It's not a super critical dimension, but I always want to have pieces that are consistent, and the way to do that is to, with each end, you're going to machine each end to do that. And also, when the drill starts in here, I have to actually use a pilot and then a drill to get that hole going. If I had to say anything about doing work on a lathe like this, it's making sure that you're consistent. So now all these pieces are done. Those are all done, okay? I just wanted to do a comparo. I had one piece that was not done. Where is that piece? Oh yeah, here it is, okay. That piece is not done. So you can kind of see how it started off. Cut across, because I did that on my bandsaw. And the rest of the pieces, when you compare it to the rest of the pieces, all the other pieces are done. So nice and shiny versus, something that's cut across. So if I had to say what is the most important thing about working with a lathe, it's a matter of consistent. It's a matter of doing consistent steps. It's a matter of doing consistent operations. It's a matter of keeping consistent with the process. If you're plugging out multiple pieces like I am, do one operation at a time consistently. And the reason I'm saying that is not just from a quality control standpoint. I'm saying that from a safety standpoint as well. Because, yeah, you can follow all directions, that it says in your lathe. If you buy a lathe, all the safety stuff, all the stuff to avoid, all the potentially dangerous stuff. But what happens when you're plugging out pieces, you tend to get in a hurry if you're plugging out multiple pieces, because this is going to be 1, 2, 3, 4, 5, 6, 7. This is going to be 14 orifices when I'm done, okay? I'm going to cut them off the ends of here. This is going to end up being 14 orifices. As you go through each step, you tend to get hypnotized, or maybe you get cocky or whatever it is, and you maybe don't lock one of these into the chuck right, and it starts to spin around and knock all over everything, you're going to get hurt, or something's going to get hurt, or something's going to happen. And that's because you went out a step and you weren't consistent. And that's I think out of everything as far as working with a lathe is concerned, that's the most important thing to remember when you're working with any machine is consistency. Consistent steps, consistent operations, consistently drawing the the cutter in the same direction each time, starting from the same point each time. Consistency. I can't say that enough. And that's how you get both quality. That's how you keep your quality in your pieces, and it's also how you stay safe. So remember that, if nothing else, from this lesson. And like I said, I'm not a professional guy with a lathe. There's other safety things that you need to know, so make sure that you read your manual and follow those instructions. I'm just a basic layman that happens to use a lathe to crank out products that I use in the things that I work with. So there you go. Okay, so now I'm going to switch over from facing the material, this is what they call facing, okay, to actually cutting this hex stock into a round shank. And that's going to produce, this portion of this piece, okay? So I've already determined that it has to be a 1/4 inch wide when it's done. So I'm going to, consistently cut and cut and cut. And then what I'm going to do is occasionally I'm going to go in there with my calipers and just measure the cut to make sure that we're at a 1/4 inch. And it's actually going to be 0.247 is what my spec was. So I'm going to go ahead and chuck this piece up. And I'm going to move it out a little bit because I've got to move this in the other direction. In fact, here, let me just move it in the other direction right now. Okay, so this only goes in one direction. So about, I'm going to lean it back about 30 degrees, as you can see here. I don't know if you can see it from there. Yeah, you should be able to see that. Okay, lock it down. Okay, make sure it's all locked. Bring this out. Bring it out a little ways, because I have to bring it out a little bit further because this brings this back into these chuck heads, and I don't want to have an issue with that. Make sure that that's chucked up. Turn it on just to make sure that it's spinning centered. Okay, then I move this back over here, and then I'm just going to start to cut across here. Okay, the length of that cut has to be. Oh, I wanted to show you another thing too. If you're doing pieces, you want to kind of keep specs and keep measurements and everything. So what I did was I created a little book that has, just some mechanical drawings and some notes on the various pieces that I'm cutting. Overall, it's going to be 370. It shows how much the inside of the threads are, and then at the bezel, it's 240. Shows how wide it is. It talks about how big the hole is going into there. It just specifies everything that I needed to know going into this process. So what I'm going to do is I'm going to use those notes, and I'm going to use them to remember and to take my measurements. And I want to make it consistent. So I've got this piece chucked up in here. I've already checked to make sure that it's spinning centered. And I'm going to bring up this cutter up here. Now, the other thing too is that, okay, I was talking about some of the adjustments that you need to make on these machines. As you can see, I've got a piece of shim stock stuck in here. That's one of the things that I'm talking about, the adjustments. And the reason is because this had some movement in it, and you can't have any movement in it, obviously, if you're spinning at a high rate of speed and you're cutting something, because then you're going to get, a holy mess up here. So I put a piece of shim stock in there just to make sure that this is not moving. I mean, obviously there's a little bit of a tolerance of maybe 1 or 2 thousandths, but I got to make sure that this thing is going to consistently move across the rail and not wiggle. So that's what I mean by setting up the lathe. And for each lathe and for each situation concerning machines, it's going to be different. So I'm not going to get into any of that discussion here. Okay, so basically I'm going to bring this piece up over here and just bring it to the edge. Bring it up to the edge and just kind of turn it over here. Well, let me just bring it over here. I'm going to turn it over. I'm going to turn it over until I'm going to bring it up to there until it's just barely touching the edge of that. There we go. Back it off a little bit until just barely touching the edge of that. Another thing too is as I turn these dials, okay, as I turn this in and out, okay, there's a little bit of play in here, okay. there's just a little bit of play in here of about, I would say about 5 or 6 or 7 thousandths, okay? So when you're moving in one direction, you always want to make sure you're against the movement of the, you want to make sure that you're against the movement of the thread, because it's a threaded, piece that allows that to drag across there. So you always want to make sure that you're up against that, so that as you go through and as you're measuring, these are your measurements right here, you're consistent with how much that's actually moving. Otherwise, if you're backing it off and you're trying to move forward, you don't know where you started. So I always zero this out when I start off with. So according to this, that's my zero measurement, okay? I'm right here at the edge of the stock. I'm going to move back now a little bit, and then I'm going to move forward. So I want to back it off a little bit. I'm going to move forward to where I'm right at the edge of that stock, okay? So I'm just going to go ahead and move up, and I usually use a magnifying glass to find that. I've got to get that set up right. Well, actually, what I've got this camera on is actually holding. That's normally what I hold the magnifying glass with. So let me find my magnifying glass. I'll be right back on camera here, and then we'll kind of go through that process. Okay, so now as I start this cut, what I've done is I've located the head of the cutter right at the very edge of the bar stock, as you can see here. Okay, it's kind of hard to see that. Okay, right at the very edge of the bar stock. That's where the cut's going to start. This cutter is right there at the edge in both this direction and that direction. Okay, and that's because I need to have a consistent cut. What I've done is I've zeroed out my scale. So let me move back here. I've zeroed out the scale. It's at 0 right now, and that's how I'm knowing where I'm starting here. But also I have to zero out this scale, and remember I've got some play in here, so I've already moved it in that direction. Now what I'm going to do is I'm going to zero out that scale, and this is the critical one right now for me as far as I'm concerned, because this is going to tell me how far in I have to cut on that piece of stock. Okay, I do it 10 thousandths at a time, a cut each time. Okay, so as I make my sweeps, each time I'm going in 10 thousandths of it at a time. That's what works for the brass that I'm doing at the speed that I'm doing it, using the type of cutter that I'm doing it. Obviously, you're going to be all over the map when you talk about different scenarios, different materials, different speeds. Just everything's different for every type of material. So that's where you kind of have to get the hang of using a lathe. So now I'm zeroed out here. I'm zeroed out here. This part's not really super critical because yeah, I'm going to know about when I'm getting to where I'm going, because I know more or less how big this stock is. But this is the more critical part for me right now when I start. And then this will become critical as I get closer to the final dimension that I need to get to for the diameter of the shank. So what I usually do is I make a deeper cut here to start off with, and then I try to get to where I'm right at the edge of that cut, because it is bezeled going in, and as it cuts deeper, this face of this cutter right here, I don't know if you can see that. Okay, well anyway, the front face of the cutter is going to come into contact with that bezel, and it's going to want to make that cutter move and choke the piece, which will eventually, if it gets caught, it'll bend this shaft. So I don't want it to do that. So my first couple of cuts are deeper, okay, and then the last couple of cuts are, probably about 1,000 to 2 thousandths off of that, where that final cut is. And excuse me, I am going to have a slight bezel to it because of this is being angled back. Okay, so I'm going to go ahead and go in there and start to cut, and I've got to cut according to my specs here. I've got to cut a length at all right, so 0.200 is what I'm looking at. 200th in, but where the bezel is, it's actually going to be 240 from the back of this to the outside part of the bezel. That's going to just be automatically done because I've got this angle here. But the actual cut that I'm making at the very tip of it is going to be about 200ths of an inch. Okay, 0.2. Is that right? Yeah, 0.2. Okay, so I'm going to go ahead and do that. Turn this guy on here. I've already centered my piece, obviously. Okay. go ahead and hold on to here. Now I'm going to go in about, you can hear it starting to cut. Go in about 10 thousandths to start, okay? And I'm going to go ahead and do this. Now I'm going to count off on this scale when I get to 200ths. I'm counting off on this scale. So right now I'm at 40. The scale's got increments that go up to 40, okay? 40, 80, 120, 160. Next time I come up here, I'll be at 200. There, 200ths, okay? So that's 200ths of an inch deep. I'm going to back it off. Back it out a little ways just so I get this scale back to where it's on scale, okay? That's a 200th of an inch cut. So as I go further in, this will become more of a bezel there, and this will become like more like 240, I think it was, is what I measured it out to be, and that will be 200ths. And I want to make sure that I'm consistent here. So yes, I am. Okay. So that's how I'm going to be doing it. So I'm going to keep cutting it. I probably won't come back on camera until I'm closer to the end of the cut. Oh, okay, yeah, I do want to make one more sweep just to show you. So each time that I'm going in about 10 thousandths. I don't want to make super, super deep cuts, or I don't want to get super aggressive with my cuts. So I'm only going about 10 thousandths of an inch each time, and it'll take me several sweeps. I think it's about 5 or 6 sweeps that I have to go before this shank ends up. And as you can see, it's starting to become more round. It's still got flats on it, but as I go in, I'm going about 10 thousandths at a time. Okay, so let me go ahead and go. Whoops, turn this guy back on. Okay, so I'm going to go in about 10 thousandths. So I'm going to bring it up to 20 thousandths. Just wanted to kind of show you that, okay? And this here, so I'm going to start it at 0. I don't have to move the scale. Okay, that's 0 right there, okay? So from here I'm going to go another 2/10. So let me go there. I'll make this cut while I've got you on camera. 180, 120, 160. All right, there it is, 200. Okay, I'll make one more sweep. As you can see, the barrel of this is now round. So I'll go to another 10, and I go back to there. I'll get it back to 0 again. And there's my 0, okay. Now I'll start again. 40, and it is becoming a little bit more aggressive as I cut, so I'm just going to spray a little bit of this juice on there. There's 40. 80, 120, and I'm watching both here and there just so I know what's going on at all times. 120, 160, and 200. Okay. So I'm going to go ahead and shut it off. Okay, so now you can see I finally rolled it to where I've got round stock here. Not quite close to where I need to be. As you can see, I still have to make a few more cuts here. Probably, I would say about another 2 or 3 cuts to make that to where I need it to be. Okay, that's going to give me the part that I'm going to end up threading on that little piece there. So I'll come back on camera once I'm closer to the end of it. Okay, so if you remember, I told you I had to cut the shank down to 0.247. Okay, so that's a 1/4 inch, basically. Okay, if it was 250, it'd be exactly a 1/4 inch. So now what I've done, I've cut it down a little bit. I'm just going to go ahead and measure it. Now, when I measure it here, I'm not going to be using the sharp part. I'm going to be using the anvils on this to make sure that I'm not going in any valleys or anything like that. And I'm just going to go ahead and measure, take a measurement, and it appears that I'm at 283. Okay, so the next cut that I do is going to go in 10. It's going to take me to 263, and then I'm going to make another partial cut to bring me to 247. So 263, then I'm going to go about 7,000, 6 or 7 thousandths after that. It's going to bring me to 2.47 or 0.247 where I need to be. That's why I measure this as I go along here, and I just got to measure again here. Yeah, oh, I'm not exactly zeroed out, so let me zero this guy out. Oh, I was zeroed out. Okay. Just make sure. And I always kind of make a couple of passes at it to make sure that I'm on the button here. Okay. Oh, it looks like it's... Hang on. 92. I must have moved it in after I took it off. Okay. 92. Nope, it's about 87, 88. Okay. So... that's why I take a couple of measurements there. So I'm going to go ahead and go as planned. I'm going to end up at 2.47. So I'm going to go ahead and make another sweep here. The next one's going to take me down to, since I'm going 10 thousandths at a time on this scale, it's actually taking me 20 thousandths of material off. So I'm going to end up going to 277. I'm sorry, 267. I'm going to make one sweep, and then the next sweep I'm going to do my partial sweep, probably about 5 thousandths, which will give me about 10 thousandths in a cut. So I'll go ahead and do that right now. Okay, so my goal for my final dimension on this turned down piece of shank is 247. So I can be within 3 thousandths of that. So right now, let me measure it out here. Put it on the anvils. It looks like I'm at 248, so I'm a thousandth off. It's not even worth machining for. And the other thing too is what I'm going to do is I'm going to bezel this a little bit. I'm going to end up cutting a little piece off of the end here just to make it easier to put the tap on there, because I've got fairly straight cut taps. I don't know why that tap doesn't tap onto this, but so I'm going to bezel it just a very little bit at the end once I'm done with all these, turning all these pieces here. I'll bezel a little bit just to make sure that I'm able to start that tap fairly easily. Otherwise, if I can't start the tap easily, there's a possibility that the tap, once I put it on there, is going to skew a little bit, and it's going to screw up my threads. So it's just, again, it's a matter of consistency. Okay, so I try to run a bevel edge at the bottom part of this shank here, because the shank's going to be threaded, and I need to start the die on here when I cut the threads. And sometimes when it's squared up like this, it's hard to get that die on, so I just put a slight bezel on there, or bevel on there, just to get that die, make it easier to get that die started. It's not anything that you're going to really see with the naked eye. You got to kind of look at it. I could do it a little bit deeper, but I do it fairly shallow. And the way that I do that, I don't use cutting tools. I could use cutting tools. I mean, I could create a whole other operation and cut in this angle at like a 45 degree, but instead of setting up my chuck for a 45 degree cut, I just kind of turn this machine on very, very slowly, and then I just run a file along there, and what that'll do is it'll take a little bit of meat off of that, just kind of at an angle. I make sure that my fingers are away from the chucks here so I don't get hurt. The other thing too that you might note, I don't run my lathe with a shield on there. These lathes actually come with a shield on there, and that's because I actually stand to that side of the machine when it's turning. So, and I wear glasses when I'm working with machinery, because I have to be able to see in very tight tolerances, and sometimes I use a magnifying glass, that type of thing. So as far as I'm concerned, I'm already protected. I guess I'm kind of taking a chance. I mean, follow the manufacturer's directions when you get your lathe, obviously. But for me, I'm just comfortable, wearing glasses. I know that they're going to be covering my eyes. I can wear a face shield too. I used to do that when I first started working with this lathe. But anyway, getting back to the bezel, here's the bevel edge now. So I've got something that I could actually. It's going to be easier to start the die when I cut these threads here. Oh yes, one of the other things I wanted to point out here. Okay, so since I'm cutting at an angle here, okay, onto you know, when this is actually not a straight cut, it's at an angle. There's a little bit of a bevel as you can see here. Okay, beveled edge. So I have a tolerance. I know how much thread I have to have from here to the inside part of, you know, I need to know. I know how much thread I'm supposed to have here, but I also have a spec for how much distance there's going to be from here to the bottom edge of that, and it's going to vary depending on how angled the cutter is going into there. So usually what I'll do for the first cuts, I'll go to the maximum of that depth, and I'll start there, and then I'll back it out, usually about 3 mil every time. It just depends on the average of the cut, but the first few cuts I do it to that actual edge there, and then as I go deeper and deeper into the material, I back it out more and more, you know, in that direction, so that I end up with a beveled edge. And it's really going to depend on what that angle actually is and how deep that you're going in with the cutter each time, because that really is going to be determining what that factor is going to be. So, you know, it's going to help to be able to manage this with a little bit of trigonometry if you want to go that far, or just, you know, use your brain and figure it out otherwise. And that's how I'm able to do that. So now, since I've cut these shanks now, what I'm going to do is I'm going to cut the top of this with the bandsaw longer than it needs to be, so that this has a shoulder, and then I'm going to flat cut it across just like I did on the bottom of these, just to flatten it so I have a nice flat edge. And then the final operation is going to be, you know, drilling into this end so I have a hole to go into. Since it is a gas orifice, it's got to flow gas. So I'll continue on with this, and I do cut this further than it has to be, and then I machine it back. I kind of know how consistent I can cut with my bandsaw and how inconsistent I can cut with it. So, you know, that kind of gives me an idea of where I've got to cut to begin with. And I do notch these for that cut so that I know where I've got to start that cut. So I notch them here on the lathe with a cutter, and I'm going to do that here in a second. So, okay, just bear with me. Okay, so now what I've got is I've got a length that I cut this to. Okay, so I have the spec of what that length has to be. When I machine it down, I machine it to that length. Now, I could cut this with a parting tool, which is not what this is. This is a different tool altogether. You know, which is normally what it does is it cuts into the material, it cuts it off. It's a cut-off tool, okay, or a parting tool, whatever you want to call it. Okay, and that's the machinist term for it. There might even be another term for it, possibly, but what I do is I just find where the bottom part of this is, and then I go in however much the length of this has to be, and then some, to make up for the blade that I'm going to use on that hacksaw to cut this with. And as I said, if I had you know, if I had the quick release chucks on here, I'd just throw that on there and I'd cut it off, because then it'd already be set, because it'd be in a chuck and I know it'd be consistent every time. But I don't have those quick release chucks right now, and I don't want to have to align a parting tool to go into here, you know, to cut into this material properly, because it's got to be exactly centered for that tool to work. Otherwise it'll bind, it'll move, it's a real mess. So I'm going to just go ahead and move this over that much. So I've started it here, okay, now I'm just going to go here, and I'm going to move it the distance that I've got to go. So I'm zeroing out my scale right now, and I go that distance, and I give myself enough for half the blade width of the bandsaw that I'm going to be cutting it with. So in this case, okay, so I'm at, let me just go ahead here. I'm actually at 0.370, so let me just go, okay, so there's 40, 80, 120, 160, 200, 280, 240, 280, 320, 360, and then 370. So now I've gone the distance. Now what I'm going to do is I'm going to go a little bit more to make up for the width of the blade, which is about another, yeah, it's about another 5 or 6 thousandths there. Okay, so now when I cut, I'm going to put a notch on here. So let me go ahead and do that. It's going to notch it out. And I'm going to go. We'll go a little bit further here. I'm going to go to about 7 instead of 6. Okay, so now it's notched where I'm going to cut it with the bandsaw. So when I'm going to lay the bandsaw part on there, even if it cuts crooked, it's still going to be within tolerance once it's done, because I've done this operation before, so I know kind of what the tolerances are. And you gotta get to know the machinery. The other thing about this too is when you're using the lathe, you're going to feel certain resistances. You're going to hear certain noises. You're just going to get intuitive the more you use your machine. So I know how far over I can go with a cut based on what the noises are, what the feedback is. I can actually feel the machine operating through the knobs. When I'm turning these knobs, like this crank right here, when I'm turning that, or this crank right here, I can feel how that cut is going, and I know whether that tool is going to bind in the material that I'm cutting or not. So it's just kind of a matter of using the tool and getting used to it and knowing what the feedback that the tool is going to give you as far as how far you can take something, how consistent you can be with it, what the absolute limit of it is. You just kind of get a feel for that after a while. And this lathe's got a lot of limitations because it's just a little hobby lathe, so you have to work within the limitations of the machine. I mean, if this was a master machinist lathe, then yeah, I'd have no problems. I could do anything with anything, I know, but you're still going to have limitations even with that, and there's still going to be a certain order of operations that you have, and there's still going to be a certain protocol that you have to put in place to be able to get around the deficiencies in the machinery that you're using. So just a word of wisdom there. So now I've got something here that I'm going to go ahead and put in my bandsaw and cut off. And once I have those cut off, I'm just going to machine the end flat, and then I'm going to drill this end. I'm going to put it back in the chuck. I'm going to put my little drill head back on here. I'm going to drill the end in, and I'm going to be good to go. So I'll be back. Okay, so I did mention the cutoff tool before I got into the tangent of having to do this, cut this piece here on the lathe. And a piece is still chucked up in the vise there. You have to have, I'm going to be adding on to this, like I said, so I'm going to be adding a multi-tool that actually I'm just going to slip the parts in. They are going to be adjusted for the, and centered on the piece, because every cut that you make has to somehow be centered on the stock that you're using. I'm using hex stock here. Most of the lathe people out there, most of the stuff that you're going to be doing is probably going to be round stock. I happen to be... I do a lot of hex stock, okay? So, but I cut round pieces because I have to thread, the pieces. So the cutoff piece that I was mentioning is going to go into a chuck, and once I have that chuck set up, it's always going to go to center, and I'm just going to, put the piece in there, snap it in, and go. I can't seem to get this out of here. Anyhow, okay, you can see the piece in here, okay? So it's got a cutoff piece on the edge here. Now this piece is slightly bezeled, so you have this piece, but it's going to have like a cut it's going to have the end that's going to be slightly like this. So that indicates how you actually put this piece into the cutoff, to be able to cut off the piece that you're doing and where you're actually going to start that cut. And you'll get used to using the tools as you use the lathe. The other thing too is this is a starter kit of various cutters. This is just common steel, okay? But I like to use carbide cutters, so that's why I'm using some of the more high-end cutters on here. And that's because, I just want to make sure that I'm going to be able to have extended tool life. Carbide, like any other material, it has to be sharpened every once in a while. So, if you're going to be doing some sharpening, what I did is I went down and, to the dollar store and got myself some of those diamond nail files, because diamond is harder than steel, and it actually does a pretty good job at sharpening these cutters that I use. And the other thing too is that, if you're starting off with a lathe, I went on the internet well, this, first of all, that's the lathe right there, okay? But I went on the internet and got myself a manual. You know, this thing was published like in 1905, so I went and got myself a manual that, you know, just kind of walks you through some of the various steps. You know, if you're starting off with a lathe, handy little thing to have, you know. I've had some experience with a lathe, so, you know, I'll go in there every once in a while and look up stuff just to see how it's done, or you know, get some ideas. You know, the thing about lathe is it is kind of a creative world. You know, there's a lot of different ways to do the same thing, and, you know, you just want to figure out the most efficient way to get through the work that you're going to be doing. And, you know, you're going to be using a variety of tools. I mean, you can use a number of different tools to accomplish the same thing. That's the beauty of using a lathe, you know. So I've got the piece chucked up in here. I've already scored it like on the last step here. Now what I'm going to do is I'm going to do all the rest of the pieces. I'm going to score them about the same spot there, and then I'm going to go ahead and cut them off with the hacksaw, since I don't have the attachment to be able to hook this in there. I've done this before. I actually did attach the blade and, you know, was cutting it and stuff like that, but without this being exactly centered every time and without having the right setup, I really don't want to go through cutting it like this, because it is a pain in the ass if you don't get it right. You'll ruin more pieces than you'll cut correctly. And you know, I just score it, hacksaw it off, you know, on my electric hacksaw, and then I just do it like that. Then I go back there and reface it, you know what I mean? So basically that's it. And okay, so I'm going to come back when I've got all these pieces done. I'm going to put them on the hacksaw, cut them off, and then I'm going to face these individual pieces as we go along here. Okay, so now it's time to cut off these pieces. So, you know, just have my basic mechanical or electric hacksaw here. And I'm just going to go ahead and chuck the pieces in there and just cut them off one at a time. So, let's get this thing all set up. It moved a little bit. Make sure we're cutting it off square there. Okay. And just going to go ahead and put them in here. Line this guy up and then do the cutoff. I've got, I don't know, probably a dozen of them to do. So I think I do them, what, a dozen or 2, 4, 6, oh, that's weird. I have an odd number. I'm going to be doing 14 at a time here, so just do them one at a time. I line up the mark with the score that I did on the lathe. Just make sure it's lined up. I'll kind of bring you a little bit closer here. So it's lined up with the score that I did on the lathe. And, you know, that mark right there is about as wide as that blade is. I've done this before, and then I'm just going to go ahead and cut it off. Usually I'll run a little bit of WD-40 through there, just so it doesn't overheat. And oops, gotta plug it in. Anyway, so I'm going to plug it in. I'll go ahead and give it a shot here. Alright, so I'm going to go ahead and turn it on. And it just drips through there like butter, basically. I think I'm slightly off on my cut. It'll fall off to this side over here, so I just expect to catch it. And, you know, the saw turns off automatically when you're done. So I'm going to cut all those pieces there, and then I'm going to machine them down to the size that it should be. Okay, so now I have my stock here. So, you know, cut them to a little bit longer than the length they have to be. I'm going to machine this side down, and then they're going to be done to size. One of the things that I did when I did that bandsaw was I was trying to hold the camera and do the bandsaw at the same time, so I left the blade on the piece. You know, you should never start a blade on the piece. You should drop it down on the piece just to make sure it's lined up. So the rest of the cuts came out okay. That one went a little bit long, so just to correct that. Now I'm going to go ahead and machine the tops of these pieces down to the size, and then they'll be to that spec that I had for the overall length of this orifice. Okay, so now I'm going to go ahead and set it up for cutting here. Now I've got this separator here. Well, actually this cutter right here set up. I'm going to go back to the other cutter that I was using. So it's going to be done with this one. Only in this case I'm going to tilt it in this direction now, so I could drag the face of this cutter along the axis, or yeah, along the axis of the orifice. Okay, we put this in here. So now I'm going to be chucking up the round part of it, so I need a smaller piece of chuck. The other thing too is that when you put these in here, you want to make sure that they're centered. So sometimes you'll see guys tap them in there with a plastic hammer, you know, to make sure that they're okay. I just kind of give it a little bit of a spin to make sure that it's that it's chucked up properly. I'm going to drag the cutter over here, and I'm going to cut from the center out. So I've got to get an estimation on the center. Let me do this, and again, I'm cutting on this side of the piece, so this part's rotating in that direction. If I was cutting on the other side of the piece, I'd be rotating in the opposite direction. So you get an idea here. And I'm going to go to about center here, and I can kind of line it up by putting the corner there and then just lining it up like this. You know, I mean, it doesn't have to be super exact. This isn't really super precision work, what I'm doing with these. Now, if you're doing precision work, obviously you're going to be using other methods of measurement to figure out where you're at on a piece. So I'm just going to go ahead and turn it on. Run that piece into the center of it. And then just bring it out a little bit just to smooth out the face of that. Still not cut evenly, so gotta drag it in maybe another 10 thousandths here. Okay, and I should have something show worthy here. So now I'll just take it out of the chuck. You know, I'm going to measure the overall length of this. It should be within my tolerance. And, you know, that's what you get. So you're going to get a piece that's faced off like that. There it is. Okay. Nice bottom piece. Now, obviously, I've got a solid piece here, so I'm going to end up drilling in this side here. That'll be the next operation that I do. And, you know, the purpose of this video is just to show you basic machine work. I don't do any super elaborate work on this machine, but, you know, crank out these little pieces. You know, I got to crank them out every once in a while because I'm working on a project where I need orifices. Can't find the orifices, so there you go. All right, I'll be back on camera once I'm ready to bore that out. Okay, so now they're all cut on that end there. So everything's, you know, they're all within spec and everything. I've inspected them. One of the other tools I forgot to mention, if you have a lathe, and it's kind of a must-have depending on what type of operation you're doing, dial indicator. That's going to be real handy for cutting, you know, down to the right size and being able to figure out and having repeatable steps. So I don't really use a dial indicator very much because I'm usually measuring these pieces. This is mostly what I do on this. So I'm usually measuring the pieces, you know, the diameter of the barrels. But, you know, a dial indicator would be something handy to have if you have a lathe. And okay, so now what I'm going to do is I'm going to go ahead and take these pieces and then I'm going to bore the end of them so that there is a hole on the inside there. And I won't show you threading the pieces because that's kind of useless, but, well, maybe I will. I don't know. We'll see what happens. Okay, so another operation that you're going to be doing on a lathe from time to time is going to be center drilling. Okay, so what I'm going to do is I'm going to put a hole in the middle of this. Okay, so, you know, I use a standard drill chuck. This is the size that it's going to end up being. But to start the hole, I use one of these guys because this is going to find center. Now, the interesting thing about using a lathe to do, you know, to drill a hole, is that the piece is actually spinning and not the actual drill. Okay, so this guy here, this thing just snaps into here. Okay, it's locked into place. There's an indicator on here to indicate how deep you're going. Now this piece is actually wider than this piece, so what I'm going to do is I'm just going to get the hole started on these pieces, and then I'm going to, you know, I'll start all the holes, I'll put them, chuck them in, start all the holes, and then I'm going to, you know, drill them with this to the depth that I need to do it with. I'm going to use the scale to figure out what that depth is. And the other thing too is that sometimes, well, I could do it one of two ways. Hang on one second here. I'm going to use the scale, but I'm also going to put one of these collars onto the drill bit, just so I know that I'm not going deeper than I need to, because if I go too deep, you know, I'm going to drill through the face of this guy right here. So I just want to make sure that I have consistent holes, that they're consistently the depth that they need to be. So basically just chuck this guy up in here. Okay, this thing comes loose, so I'm going to go ahead and move it over. I'm going to move it up to the piece. Here's the piece that I'm doing. So now this part's critical here. You want to make sure that you've got this centered. This is hex stock, so you know, I've got 3 jaws here, so that means that 3 sides of this hex stock are actually going to be against those jaws. But the trick is getting it in there straight. You want to make sure that when you turn it, you want to do a test turn. You know, you want to make sure that when you're turning it, it's turning consistently and not wobbling up and down. If it's wobbling up and down, you know you got it in there crooked. So basically, just kind of put this guy in here. Well, let me go ahead and open it up, because I've been using the other side now. And I just kind of wiggle it around a little bit to make sure I've got it in there, you know, that it's seated properly. I'm going to go ahead and give it a test spin, make sure it's okay. Yeah, so it is consistent. I'm going to bring the bring the drill bit up to the piece. I'm just going to do a little bit of a bore, start a little bit of a bore, just enough so I could fit the head of this drill bit in there, so I could know that it's centered when it goes in there. So I'll come back when I'm ready to do that. Okay, so now I'm ready to get my starter holes going now. So I'm just going to turn it on. I usually go at pretty slow speed when I'm doing drilling action, just because that requires a slightly different speed than the machining action. So I just kind of bring it up to here. As you can see, it finds center there. That piece is already centered, but sometimes you'll see it to where the bit's wobbling around a little bit, and that's because it's finding the center, and maybe the center's a little bit off, I don't know. But you know, you definitely want to make sure that that shank is centered into that chuck. And I'm just going to go ahead and drill through. Oops, I didn't tighten it down enough. I'll go ahead and tighten it down, and I'll be back on. Alright, so back on camera here. I forgot to tighten it down. Alright, so now we just go ahead and run it through there. And, you know, you could either spray WD-40 in there or not. Well, I probably will, just to make sure I'm not going to overheat it. I don't want to distort the holes. Just kind of take it through there. And just get it to the point to where it hits the shoulder. That's going to give me enough to get that drill bit started. Back it out, turn it off. Just wanted to show you here. So now I've got a pilot hole started here. So once I run this drill through there, you know, it's going to drill it out to the correct size that it needs to be. And these aren't super critical, but I do have a specified size on this just the same. So that's basically it. I will probably walk you through me drilling them out, and then maybe even tapping the pieces. So I've started the hole on these pieces now, okay, with that countersink set, the center drill countersink set, okay. So now what I'm going to do is I'm going to go ahead and drill them through. So obviously I don't drill all the way through, so what I do is I'll just set up a drill like this with a collet on it, and that's how deep it's going to go. So that's going to act as my depth gauge. I'm going to stick this in here, so I've actually got to move the chuck back, because the drill bit's longer than that other piece was. Chuck it up in there, and every once in a while I've found that with these with these collets here. Every once in a while I have to check to make sure that they stay the same depth, because they do tend to creep back on a drill bit, and probably because the drill has flutes in it and it doesn't, you know, this set screw doesn't grab on to the drill bit as well as it should. So now I'm going to go ahead and move it forward. Well, I'm going to move it forward a little bit more here. I've got limited room on these. Another downside to the mini lathe is that you have very limited movement. For me, it doesn't really matter, but if a guy was going to really need something, you know, you got 10 inches to work with here. You could theoretically work on a 10-inch shaft, well, probably a 9.5-inch shaft, because it is rated at 10 inches. So you got some limitations there, you know. I'm going to go ahead and put my little piece in here. I'm just shaking it to make sure it's going to fit correctly. Spin it. Okay, so yeah, we are. No. We're a little bit wobbly there. So let me get this just right. Okay, now we're centered. So I'm going to just go ahead and drive it forward into the piece to the depth of that collet. And this actually does a lot more of an efficient job than drilling than the other one does. Okay, I don't want it quite to touch the collet because I want to make sure that that collet stays in the same place. So I'm just going to go ahead and do them all like that, and what I'm going to end up with are pieces that have a hole drilled in the center to a certain depth, to the depth that I specify. And then, you know, once I'm ready to put them in whatever piece I'm going to put them into, you know, I got to drill out the hole, you know, to the right orifice size, and there you go. So that's basically it. You know, maybe I don't know if I'm going to show threading it. I don't think that's useful for this video. And that's basically how, you know, the basic operations of working with a lathe. Now, you can actually do a threading operation on a lathe like this. What you have to do is you have to set up the gears correctly, and then there's a counter here, and it'll actually drive it in for you. It'll run a threader. You know, you run a little thread, like a little cutting piece along there, and it just cuts it. You know, it'll just run it up, and then it spins the head of it at the right speed and feeds it in at the right speed to get the thread that you're looking for. But I don't like to do threading like that. I mean, for me, a simple die is going to work for that. You know, I like to use dies. I know exactly what I'm getting. I know the depth that the threads are going to be cut. You know, because when you're doing threading on a lathe, you gotta cut one depth, then you got to start another cut and cut even deeper, and you know, just go to the specified depth that you want. I mean, that's basically 3 sweeps on the material. So it's a very inefficient way to thread something, but it would work if you needed to do something where you didn't have a die for, or die wasn't available, like very odd threads. I can't think of what that would be, but there you go. So this concludes the video on the basics of working with a little machinist lathe. Thanks for watching.